Hello, everybody. It's nice being here today. I'm James, first of all, and today we're going to be talking about Android being open source and what it means for us after all. So we'll explore all about Android's open source nature via the Android open source project, and we'll see all its benefits. So firstly, we need to see how and why is Android open source. So we know that Google is in possession of the Android trademark and the Android source code. And when developing the source code, Google opted to involve the open source nature of it via the Android open source project. This means that all the platform, device, and kernel repositories needed for Google devices and Google source code to make Android are open to the public for no extra cost. So whenever this question is mentioned, why is Android open source, I like highlighting three main keywords: distribute, establish, and expand. So Google distributes these repositories to establish the Android ecosystem when synchronized together in an Android environment. Now, these repositories work on one another in a dependent and efficient way so that the environment can be compiled and obviously tested together. This nature helps expand the popularity of the operating system along many OEMs and device manufacturers, obviously to establish Android as their main platform. So let's open up. Over here, we may see an endless list of repositories over here. So this is the website Google uses to index all these repositories. And you might be asking, which should I use? So whenever we're developing in an AOSP environment, we need to consider not just one repository at a time, but all of them in an Android environment. So this means that once synchronized, you can then modify your select repository to make changes in the Android environment and eventually, once compiled, in the Android operating system. So that's what all these repositories do. Later on, with a combination of compilers and many other packages, such as GCC and Clang, these compilers can help compile the kernel and later on the firmware for a flashable zip file which can be sideloaded onto your device. So let's make sure that we're ready before we can get building, of course. So we need to follow the requirements. We need to make sure that we have the hardware requirements, enough space to synchronize all of this code. Software requirements, such as the latest distribution of, for example, Ubuntu. Device binaries, which are usually supplied by the OEM for device tree, kernel, and vendor blobs. And finally, the build tool chains to ensure that our environment can later on be compiled. As mentioned before, the compilers can be GCC, Clang, and later on you'll also need Bison. Packages such as repo and JIT will be used later on to synchronize and implement any new repositories. And that finally establishes a build environment. So let's speak manifests. This is initially where we start off with when we want to synchronize the Android source code. Of course, manifests can be used all around Android. You can see them in the framework repositories, device repositories, and many others, obviously even in app testing and developments. But today, we'll be looking at two repositories, manifests, which will help us initialize the Android source code. So the Android platform manifest is shipped with AOSP. It is a simple XML file, which is used with the repo tool so that an index of repositories can be synced from a source and to the right destination. This obviously establishes the environment, and with it is a branch and a tag for which Android version you would like to develop or synchronize. It depends on many things, of course, the source, the branches, the tags, so in all, they are synchronized together. Now, local manifests are custom manifests which can be added on to the manifest.repo directory. And local manifests are made from the developer. So if, for example, I'm developing for a separate device, not a Google one, which is synchronized by default, I can add another XML file with a source, such as GitHub or GitLab, so that I can synchronize my own source code before I make changes to the environment. You can also remove some repositories so you can save resources and, of course, waste less time. So downloading the source code is as easy as literally 3 steps. As you can see, I'm making a directory here. No big deal. And with the repo tool, I am listing the manifest and the branch which I want to develop with, which is in this case Android 12.1, Android 12L on branch R7, which is the June security patch. Finally, once repo is synced, which could also be specified with how many resources via the -j flag, we can get building. So the same way as I said with synchronizing the source code, building also takes 3 steps, granted that your environment and your device target is set up properly. So firstly, we run this script called envsetup.sh, which is in the build directory. This script is super important when later on compiling the Android source code, as many commands and implementations are used for this, as we can see when specifying the target. The launch command is an upbring from the script so that we can initialize any source code needed for a target at a specific build variant, which in this case is user debug. The build variant varies to what can be done. I mean, you can use it as user debug if you give enough privileges to the user to, for example, use ADB and extract any logs. You can specify user if it's a release build so that not many developer tools are shipped with it. And ENG is for engineering builds. So during the boot process, if there's a service which is failing and you're in a boot loop, ENG is the way to go because you can initially get the logcat from the beginning of the boot process. Lastly, we build the code via the M command on AOSP. This can later be modified to be used as make or branch, as known better. In this case, I'm specifying the target OTA package for a device firmware. This could be easily flashed on a device later on. So why develop with AOSP? AOSP comes directly from Google, and whenever a new Android branch or version releases, it will be available on day 1. This allows OEMs and many others to make use of this code and update it for their own ecosystem with a head start, obviously. AOSP is also known to be very basic. I mean, when you go later on and build an Android version by yourself, you'll implement newer services and more apps. So AOSP is a good sandbox for system developers and device maintainers if you want to implement Android to it for the first time. So what benefits does AOSP bring out? AOSP, it's not mentioned too often, but it's the building block for many different versions of Android. So if I'm a company and I want to build my own version of Android, I start from AOSP. The reason being that Android is divided in 6 basic layers thanks to the Android open source project, and it helps keep it uniform throughout. So if there's an update or there's an issue which has been tackled later on, it can be updated in an easy manner across different platforms and devices. So that's a very crucial development which comes from AOSP. Another thing which is gone under the radar but has been known amongst many enthusiasts are custom ROMs. Custom ROMs are custom distributions of the Android operating system with their own purpose in mind. And this helps expand the Android operating system across many different users. So let's talk about these custom ROMs. You might have heard about them, you might have used them, or you might have not. So here we are. As mentioned before, they are custom distributions of the Android source code. So say I synchronize the AOSP source code, and I want to build my own custom ROM. I can start modifying framework packages, I can include new apps, I can also add newer compilers so they can work with different devices and kernels. So that's the beauty of custom ROMs. They are used for many different reasons. They have different aims and purposes in mind. So if that's a UX or UI implementation that they prefer to go with, many users fancy, for example, they can do that. Or else they can be stable and up to date with the latest version of Android, but with compatibility in mind. So that's meaning older devices are also supported, even from 2015, for example. And some others may even emulate an experience, such as Pixel Experience. Pixel Experience emulates the Google Pixel software. So if there's a newer version of the Pixel firmware, they try to emulate it for many devices. So how are they made? As mentioned before, they're modified builds, and the environment is different from the AOSP one. They're fundamentally compiled in a similar fashion, so whenever you're developing custom ROMs or even building custom ROMs as a maintainer, they will be similar to how you compile AOSP since they're built on top of them. They also depend on components from AOSP. So say there's an unmodified version of a frameworks package, which is updated frequently from AOSP. Instead of synchronizing it, updating it later, you can just get it directly from the AOSP source code. So that is very handy. You might be asking, okay, we know how they're built, how they're made, and what they're used for, but how can I install it myself as an enthusiast? It varies across OEMs, and sometimes OEMs even prohibit or just don't promote this kind of behavior on a device, since many warranties could be voided by doing this. However, the process of unlocking a bootloader has become fairly simple nowadays, since there has been more time developing across these custom ROMs. And later, these zip files, which can be sideloaded onto a device, are flashed through a custom recovery. It's worth noting that each device has its particular version of a custom ROM, so the worries of, oh, my device could be incompatible or there's going to be bugs can be narrowed because the maintainer has all the specifications and technical aspects of the device in mind. And finally, we need to ask, are they actually safe to use? Well, it depends. I mean, the custom ROM is made, after all, with a team in mind. So this coordination of a team is quite important to make a stable experience. Here are some custom ROMs which I like mentioning over here. Lineage OS is by far probably the most popular custom ROM distribution. It is known for having many components of the Android operating system from AOSP up to date, and it doesn't have too much bloatware or extra apps, which many wouldn't use, but also has a lot of handy features such as Trust, which is used for security, and some customization options which you could tinker with. Ninja OS also has a very strict and uniform rule set, so that means that whenever a change is made, it is reviewed by many developers to be stable as possible, and OTA updates are very known, so that you can get updates even on a nightly basis, which is very good. Paranoid Android is based on the Code Aurora source code, which is compatible across specific devices. Paranoid Android also has a different UX in mind, so if that's something you're looking after, check if it's for your device and go ahead and give it a flash. And finally, Pixel Experience is one I personally worked on as an official maintainer. It emulates the Google Pixel Experience. So personally, I've developed the Google Pixel Experience for the Pixel 1, which has now run out of support on Android 10, and I've been able to bring up Android 11. And I've done this because it's super seamless for users who just are willing to keep using their devices for a longer time. So, as mentioned before, custom ROMs require quite a hefty team. These are made up of AOSP engineers and device engineers, or maintainers. AOSP engineers are probably the biggest roles in this position over here, because they keep the base code of Android in the Android environment up to date. They ensure that anything new which is implemented, such as a feature or such as a security patch being merged on a monthly basis, they ensure that it's been able to compile across all devices with a compatibility range that doesn't decrease. For example, say there's a framework issue that has been now tackled. They can merge that pretty easily. If there's a new Pixel feature drop, for example, it can also be ported for Pixel Experience. So it goes hand in hand. Platforms like Gerrit, which are used on a frequent basis for bigger custom ROMs, can be used for additional review, comments, to be further emphasized on different situations. On the other hand, device engineers have a lower but more specific and important role. They make sure that the device source code is up to date, and when a newer version of a custom ROM comes out, they ensure that the device source works with it on the latest device fingerprint and security patch in mind. So if there's a bug also which has been seen and logs have been taken, they can take the context for the logs which they have, and they can see how they can tackle it. Device engineers can also work on kernel source, so that means merging a newer Linux version so that security features can be improved, and many others. So, a future with custom ROMs. They give so much potential, so whenever I think of custom ROMs, I can only think of a utopia future with custom ROMs. So, I think we should embrace the custom work. So, people who make custom ROMs or custom device trees, they aren't employed by anyone. They do this in their hobbyist time and so on. But the results which come from this seem like it's a cooperation, more or less. However, it isn't. So I always imagine this mindset that once a device is out of support, in collaboration with OEMs, I think there could be a future where your device could last longer. And this could be very beneficial to the environment, obviously, since now people can see themselves using their phone for 3 years, but not really anymore because they're out of support. So yeah, if the slightest of foundation has been given to custom ROM makers by OEMs, I could see this custom ROM business going even further and being more stable across many users. And obviously, since you're modifying your device's firmware, it's kind of tough to promote these to newcomers or newbies, you know? They don't really want to unlock their device source code because they feel like it's something scary or something beyond what they can do. The second question being, oh, I'm a developer. What if my device, even like on a hardware basis, can't support the newer versions of Android? Firstly, nobody obliges you to go on the newer version of Android. You could support the same version with the newer security patches merged or bug fixes also being merged. However, you can always identify the problem and improvise. Throughout my Android custom ROM development story, I can come across this issue many times because I've had a device which had a smaller system image, which it can't fit the custom ROM on, and many other issues. I could say to that, for example, on the Pixel 2, with the partition issue, repartition is something very handy. And how did I come across this? The community. Since this is open source nature we're talking about here, anyone can distribute their code to everybody. And people facing the same issue with a different device could also improvise and implement this different and fixing change or whatever in a very easy manner by giving, obviously, enough authorship and contribution to the original committer. So that's all I have to give to you. So if you have any questions, kindly feel free to go up to the microphones. There are several sources over here. You can see what I have on my GitHub and on my Twitter. And I also have a site which I update monthly with the newer custom ROM developments I come about, and it's super cool if you want to get interested in.